Alright guys, so today we're gonna discuss or we're gonna learn about computer hardware components like CPU, memory and input-output devices. So if you look at the architecture of computer, it is basically made up of four different components, different separate components which have separate functions. Mainly there are four uh, main parts in a one human architecture of our modern computers is the central processing unit, the memory, the input, and the output devices. Okay, so this makes the whole uh, architecture, which we will discuss later in this lecture. So you might be interested in what is the architecture behind the computers which we use, or the smartphone which we have in our hands, or so many other gadgets which we are gathered every time in our life. How the configuration inside these computers. Now in this chapter we'll learn about how did computer become known as the stored program computer. Like, do they all have the same characteristics or there are varieties? And memory on chips and memory on magnetic media, or how do they differ? So basically, like mostly we don't use magnetic media so much nowadays because memory on the chips, it has replaced all the things. Because now we have SSDs and all these sort of things which have replaced the magnetic media type or storage type, which we had like DVDs, CDs, and these sort of things. We will also learn about how do you look for what do you look for when comparing memory devices. So we'll understand that how is information moved around within computer, and how can you help your computer run better. So is there a magic way in which you can make your computer run better? Okay. All right. So this is the architecture which I was talking about. It's called von Neumann architecture. Okay. It's named after the person von Neumann who designed this architecture. It's composed of memory, primary memory, central processing unit, and input unit and output unit. Okay. So uh, from the naming itself, or from the nomenclature itself, it is obvious that what are the different uh, functions of these parts. The central processing unit is therefore processing whatever input it gets from the input unit, use the memory to store if there is something which need to be stored, and then output the result. Okay, so that's how it works. This is the model of typical digital computer which we use in our daily lives nowadays, called as von Neumann, as I just mentioned. And the programs and data are stored in the memory, in the same memory, primary memory. The computer can only perform one instruction at a time. Okay, so that's the sort of introduction to it. Now, first thing, input-output devices or unit. It refers to the process of getting information into the computer and out of the computer. So I think it's obvious from the name itself that what is input and output. We don't need to define it further. So the input are all the devices through which we can give input to the computer. Like we can give the computer through the microphones, through the cameras, we can give it input through the mouse, through touch screens, and yeah, and we can also get output through our speakers, through the LED, or through the screens or whatever. So input those part of computers and output are those parts that provide results of the computation to a person using the computer. Now, sources of data for the computer. So there are basically two types of data stored within a computer: original data or information, data being introduced to computer for the first time. Data, let's say I'm giving some input into the computer. I'm writing something and storing it, which is the original data which I'm storing in the computer. It is first time being introduced in the computer. Okay, so computer can deal directly with printed text, picture, sounds, and other common type of information. Previously stored data or information, data that has already been processed by computer and is being stored for later use. These are form of binary data useful only to the computer. Examples: SSD, hard disk, USB are some of the storage devices. So basically, the thing is that original data means the data which is not being processed by computer earlier, which we are just giving it the input. Okay, let's say I'm talking to the computer, and it records my voice. That's original data. Okay, there are something which is previously being stored in the storage devices like SD card of the laptop or the hard disk or in the USB. There are previously stored information or data. And there are two categories of input hardware. Those that deal with original data, like the mic, it deals with the original data, and those that handle previously stored data, like the component which is used to take the input from hard disk, SSD, or USB. Those are the components which deals with the previously stored data. So these are the two categories of input hardwares. Now, input hardware could be keyboard, mouse, voice recognition software, scanner, digital camera, or so many other things. And digitizing is the process of taking a visual image or audio recording and converting it to binary form for the computer, and used as data for programs to display, play, and manipulate the digitized data. So digitizing is basically, let's say I'm talking into the mic of the computer, and the computer is digitizing my voice and convert it into binary format so that it could store it or it could manipulate it. Okay, so that's how it works. And the input hardware which is being used here is mouse, which I'm talking to. Sorry, is voice recognition hardware like mic, which I'm just talking on. So connecting hardware to the computer, hardware needs access through some general input-output connections. So there need to be some connection with the input and output in order to communicate and also get something out of the computer. So there are some sort of ports which we call as the pathway for the data to go into or out of the computer. Okay, so let's say there is a USB port, there is a mouse port, there's a keyboard port. These are so some of the sort ports. In the modern laptops, all the things are inbuilt into the computer. So as you can see, there's only one hand-free or a headset port, or we have a cable port for network, and we have USB port. These sort of things. All right, so that's just a simple introduction to the port. Then we have peripheral devices. These are pieces of hardware like printer or disk drive that are outside the main computer. USB could be also an example that are outside the computer. Or if you teach an external mouse, so that could be a peripheral device. Or if you teach a keyboard, that could also be a peripheral device. So in order to connect these devices, like the mouse which I mentioned, or the USB, or the network cable, or the keyboard, in order to connect these hardware to the computer, we need some sort of softwares that take the input which is coming from those hardwares and process it inside, make it available for our processor. Okay, so these softwares are called device drivers. Okay, these drivers are software addition to the operating system that allow the computer to communicate with particular device. For example, if you are attaching external mouse, there is a mouse driver. If you are attaching external speaker, there is a speaker driver. If you're attaching keyboard driver, then there is external driver for that as well. So there are some common basic technologies for storing binary information. We use electronic, magnetic, and optical form. So that's I think you all know about. Now electronic circuit, these are the most expensive of the three forms of storing binary information, uh, which we use most extensively nowadays. The SD card, we have the hard disk inside. Sorry, the hard, not the hard disk, but the SD card inside, or the memory, the RAM inside. These are all the electronic circuits we have. Okay, and these are the most expensive ones of the three forms of storing binary information. And electronic circuits, these could be of two types. It could be permanent and non-permanent, like the SSD card, which are in modern computers. They are permanent. Once you store something into the SD card, they um, will not be removed until unless you removed it by yourself. While on the other hand, we have non-permanent. Okay, so non-permanent, like RAM, random access memory, it's a type of memory where if the power goes off in a computer, the data in the RAM will be removed. So these are the two basic form of electronic circuits. All right, next we have magnetic technology. Two parts of to most of the magnetic form of information storage, where the medium that store the magnetic information, example floppy disk, which I am sure that we don't use anymore floppy disk because it is really outdated thing. We just for the sake of knowledge, I've mentioned it here. And it there are tiny spots on a disk that are magnetized to represent 0 as 1, and whenever reading some information from the floppy disk, then those magnetized disk spots are being read by the computer. So the device that can read that information from the medium, the driver spin on the disk. So the driver, which we just discussed about, it spins on the disk. It has a magnetic sensing arm. Like if you ever had a hard disk drive, you might have opened it up. If you ever have a chance to open it up, you must have seen that there's a kind of arm type of thing, a metallic thing, which moves over the disk. Okay, and it reads information from the magnetized spots in the disk. So that's how it works. If you haven't ever saw that sort of things, you can watch a video on YouTube regarding how the hard disk look like. Okay. All right. The next we have optical. It uses laser to read the binary information from the medium. There are millions of tiny holes burned in the surface of the disk. The holes are interpreted as ones, and the absence of the holes are interpreted as zeros, like the DVDs which we used um, or like around 10-20 years maybe back, but nowadays we don't use this anymore, I think. All right, then we have a secondary memory input device as well. These input devices are used by computer to store information and then retrieve that information as needed. So there are basically two types of memory. Okay, one is primary memory and second is secondary memory. So what is the difference between these two memory? The basic difference between these two memories that the primary memory is non-permanent, like the RAM. RAM is primary memory. It is stored uh, data for the time being when it's processed, while the secondary memory store your information as long as you want them to store them. Okay, and whenever they are needed, they are being retrieved from the place, the SD card, CD-ROM, floppy disk, whatever, and whenever they are required, they are being retrieved from that and used as per requirement. Secondary memory uses binary, and the usual measurement is in byte, as every thing is measured in byte and bits. A byte consists of 8 binaries. The binaries is standard unit. Yeah, yeah. You have the idea about that. I am sure. So the four most important characteristics of storage device. Now we discuss about memory. Okay, primary memory, which we just talked about, RAM, and then the second thing is secondary storage device. Secondary memory or storage device. We mostly call it storage devices because we store information inside it. Therefore, it's most of the time it's called as storage devices, like the SSD cards, the hard disk drives, um, the DVDs are also the storage devices. So there are four main characteristics of these devices. It is speed and access time, how fast you can access any information whenever it's required from the device. Cost, removable versus non-removable, capacity, type of access. So first we have speed or access time. How fast information can be taken from or stored onto the computer memory device or medium. So how fast we can store information into the memory, or how fast we can retrieve information from the secondary memory, computer memory. That is what we call the speed. Okay, so electronic circuits, we need uh, them to be fastest to access for billionth of seconds maybe in electric circuits like the SSDs. I'm not sure about the fastness here. Floppy disk or hard disk drive very slow in comparison to hard disk, because nowadays floppy disk or hard disk have been totally replaced by electronic circuits like SSD card in modern computers. Then comes cost. mm, Megabyte, million byte, gigabyte, a billion byte. So these are for megabyte or gigabyte of any storage devices. How much would it cost? So the two part to removable storage devices, the cost of the medium cheaper if bought in quantity, the cost of drive. So the cost of drive is mostly for USB drive. It's $15 to $100, and external SSD card is around $50 to $50. Just the number. And next characteristic is capacity. The amount of information that can be stored on the medium, like how much information can we store on any medium. For example, in USBs, we can store terabyte of data. On SSD cards, again, they're fast, and we can also store around of maybe 256 GBs into the SD cards, and more could be terabyte as well. Hard drive again, terabyte. Type of access. So type of access could be sequential, could be random. Sequential means you obtain any data by proceeding to the storage medium from beginning until that designated area is reached, like the magnetic tap. So, and random access, you just randomly pick the pick the address value from the address which you want to, or which are you required. So that is uh, that's why it's very fast, like SSDs which we use nowadays, and it is called direct access. All right, then we talked about secondary memory. Now it's time to learn something about primary memory. Primary memory is where data and program that are currently in operation. Okay, so the program which are currently in operation are in CPU are being accessed or stored during use. During the use, whenever some application is running, the data of it is being stored in our RAM. Okay, it consists of electronic circuits. It's extremely fast and expansive, and there are two type of it. Primary memory. It could be non-permanent like RAM. The programs and data can be stored here for computer use. It's volatile, means once the power is off, all the information will be lost once the computer shutdowns. And ROM, it's permanent and it's embedded into the computer. Its content do not change. Mostly the BIOS information or the computer startup information uh, or stored in ROM. All right, then the second part is central processing unit. That is, it's called the brain of the computer, right? Because it do all the task, all the processing, and all the things, and it uses the memory. It take input from input devices and give the output after processing it. So it's responsible for controlling all activities of the computer system. There are three major components inside any CPU. Okay, so there is arithmetic unit, which perform arithmetic computations. Accumulator, results of computation kept here. Yeah. So there are lots of other parts for it. It's just a simple overview of the central processing unit. Once you, it's just an introduction to it. Okay. So we don't need to dive into the concept because there are lots of other things. There are registers. There are so many other things inside the CPU which we could not address here. But later on, you'll learn about in different classes like in computer organization and assembly languages, or maybe in compiler construction. Sort of, you will also get to know about programming languages and how that things works. So you'll get a touch of CPU, the things inside the CPU there as well. And inside the CPU we have control unit, which control how any operation need to be performed. Has two locations where numbers are kept. Then we have instruction registers, which where instructions are placed for analysis. Then we have program counter, which counts the address and which instructions need to be performed next. Like the instruction from this address to this address need to be performed at this time, so the program counter counts that. Okay. Then instruction decoding unit, which just decode the instruction. Like, let's say your assembly language asks you to load something from XYZ register into the CPU. Okay, load a value from XYZ register in whatever place, and it decode the instruction what need to be performed on that instruction. So that's the main purpose of recording unit. And motherboard, this is the place where the most electronics including the CPU are mounted. It is the place where all the things. When you open up your computer or laptop, you would see that there you found a huge board, which we call as motherboard, and it is composed of all the things, including the CPU, the RAM slots, and all the other things. So now comes the output devices. Output unit display and store information using advanced technologies. We have storage devices like SSD, which replaces old drives, offering faster performance, and we have display monitor. Now, here's the thing. If you look at the output devices and input devices, you know, SSD could be considered as both because you could take input from SSD as well as you could write something into SSD. So that's why it is both input and output okay? And then we have display monitors like LED, OLED, standard high resolution display, which all we are using nowadays. Then micro LED and mini LED. These are advanced options for superior clarity. So these are some sort of display modes which we have as of now, which I'm recording this video. So like these are the modern technologies we have. Unlike the previous one, we had so many CRT, some sort of this type of things in the you know, in the like TVs and all those sort of things. Other output devices, we have 3D printers, we have augmented reality headset, virtual reality headset, we have holographic displays. These are the modern technologies we have to for an output as an output devices. So audio output devices, there are various audio output devices such as the built-in speakers or in Windows and Mac. Both have built-in audio support, but external sound card enhance quality. Uh, Audio output is useful for music, multimedia, series output, less common. CD, DVDs, these sort of things are less common because digital storage multimedia has replaced all these things. And voice synthesis, AI driven, more human like. So these are being used as well. And yeah, that's our output device, especially audio output devices are being used. Then we have optical disc or CD-ROM, which we don't really need to use in nowadays because these things have been replaced by the digital device storage devices for or storing some things. So these are not really used nowadays. So I think there isn't any need to learn more about these things, but just go through the things that how these things work. That it's a compact disk, read-only memory. By definition, CD-ROM is a read-only. Special CD drives burn information into blank CDs. Yeah, that sort of things. Okay, so storage requirement. How much storage capacity is needed? That's the main question. So if you look at the way we store our images, our videos, and all of those things, that how much storage capacity do we need? If you look at the keystroke on a keyboard, it takes 1 byte, 8 bits. One page takes 4K kbs, okay, kilobytes. 90 pages, 75 kbs. 1 second of high fidelity sound, up to 110 kbs. Complete word processing application for 8.4 megabytes. Okay, so that's huge, bro. So that's how we need storage devices. We need Nowadays we need even more storage devices. Okay, so storage capacity, we have USB flash drive around 4 GB to 2 GB, SSD cards 120 GB to 8 terabytes, hard disk drives 500 GBs to 200 terabytes, Blu-ray disc 25 GBs up to, yeah, and so many other things. And cloud storages at the end, which are virtually unlimited. Like if you want to store something on a cloud, you can store virtually unlimited data on that if the provider have that much storage. Okay. All right. So moving information within the computer. How do binary numerals move into, out of, and within the computer? So that is again a very interesting and profound question which you need to ask yourself as a computer scientist, as a computer student, because it's one of the profound question which helps you think that how does this computers, this lifeless things have been so much lively that we are hooked upon these things all the time. How, why they are they have become so much useful and so much lively if you talk about robots and all those sort of things. So we need to think about how does information is our binary numerals are moved into, out of, and within the computer. So information is moved in bytes or multiple byte code words in a word format, and information is being passed into the circuitry of any computer. Word are a fundamental unit of information. The number of bits per word may vary per computer. A word length for most large big computers with the 2 bits, it's mostly 4 bytes. Okay, keep that in mind. Just word is mostly counted as 4 byte. So this is the simple word. It has 4 bytes or the 2 bits, which makes up a word. So whenever information is transferred inside a computer, it's mostly transferred in the form of words. All right, so here are some stuff which give you the idea about how does the information is moved around inside the computer. So mostly if you look at the chip and all those things, and especially inside of our phones and all those things, we wouldn't find these ribbons type of things, but and also I don't think that in the modern laptops we have these ribbons, but we used to have and the old age computers, desktops, we used to have these ribbons inside it, which are basically consist of several wires molded together, and one wire for each bit of the word or byte. So additional wires used to coordinate the activity of moving information. So that's how the voltage pulses inside the computer were being transferred from one place to another place uh, for being processed. So example of sending word wow over the ribbon cable. So here is the thing. This is the word wow. Okay, which is 1 1 1 for each letter, and it's being passed on using the so for one for ASCII in ASCII code, if we translate the wow into ASCII, it would get something like this, the one in the bottom. Okay, so now in order to transfer these into the wire, we need to use 8 wires for each separate voltage. Okay, so we need to send each separate voltage pulses into the computer's cables. Okay, so that's how it works. The word are being transferred into the computer. Alright, so next thing is packaging the computer. So computers are of various forms. We have supercomputers, we have mainframe computers, mini computers, microcomputers, palm top computers, calculators, smartphones, and so many other things. So the many physical form of the general purpose computers all follow the same organization. They all have the primary memory, input, output, central processing unit, and they all have secondary memory, hard storage devices, and they are grouped according to speed. All that these are the groups which you can see in the diagram, or just grouped according to size and complexity of all these things. So you might have an idea about computers. These are the computers which are used for special purpose for scientific research or some sort of things, and mainframe computers, also type of computers which were used earlier for mainly for servers and these sort of things used to have a lot of used to take us a lot of spaces, and mini computer, microcomputer. These are or we can say. So these are some types of computers. Now, next thing is utility programs. I think we had discussed it in the previous lecture about what is utility program and why does it exist. Why do we need utility programs? So there are various things which we need help in our programs. Like let's say you want your computer to stay safe from viruses, so therefore you wrote some utility program for that. Okay, so that is how utility program works. They exist that can help so that they can help diagnose and solve computer hardware problems. So for major problems areas where utility programs are helpful or finding and fixing problems, testing input output peripherals, you could use to troubleshoot your input output peripherals, um, especially when you boot up um, your device and you go to the boot menu, there you can test all these things using the troubleshooting or testing mode, and testing RAM and motherboard, video card, and recovering deleted files or damaged files. So you can use different utility programs for that as well, and improving computer performance, defragmenting a disk. Like we can defragment into different disk, different parts like A, B, C, whatever, and use it do troubleshooting. Like whenever there's some issue, there are some utility programs which can troubleshoot in your window or Linux, whatever. Okay, so that is the end of this lecture. Hope you got something out of it. I hope, if not much, but you might got the idea about what really computers are and why do we how does they work, what's the architecture, and what is in the memory, why, what is the memory, what's the type, what are the types of memory, and in different input devices, output devices, all that sort of things. So that's all for this lectures. In the next one, till then, keep learning, keep asking questions, keep improving yourself. Thank you.